Hey everyone, welcome back to the channel, and today we are going to explore duck typing in Python, what it means and why it makes your code so flexible. So what exactly is duck typing? Imagine you see a duck. You don't ask, what breed is it? You just know it quacks and walks with short steps. In Python, we do something similar. We care more about what an object can do rather than what it exactly is. So simply put, if it quacks like a duck and walks like a duck, we treat it as a duck. Basically, if something behaves like a duck, we treat it like a duck. Keep this in mind. So here is a simple example. We have a dog class and a cat class. Both have speak method. Notice our function animal sound, which passes the animal, which takes animal as an argument. It has a print statement, which just uses animal class speak method. Notice our function animal sound doesn't care if this is a dog or cat. It just uses the speak method. Let's try to execute this in a code. So here we have defined our dog and cat class, and we are using the speak method in our animal sound method. We don't care if this animal is a dog or cat. We just use its speaks method. So here in main function, we have tried to do that. Let's run this code. So here we can see that the dog says woof and the cat says meow. This shows duck typing in Python. If an object can speak, we use it, no matter what class it is. So here we don't care if this animal is dog or cat. We just use its speak method. If it has a speak method, we just use it. We don't care what the object is. So what if a method is missing? Now let's see what happens if we pass an object. Let's see here we have a rock object and we pass an object which doesn't have a speak method. Here a rock object is missing the speak method. So our function will fail. We catch this error with a try except block. This is the risk with duck typing. You must be sure that the method exists or we should handle the error. Let's see in the code. Here we have defined our rock class and we are trying to use its speak method by passing this rock class object in this animal sound method. Here we will be getting the error because of the duck typing, because we don't care if this animal is of which class. Yes, we care about its method. So if instead of checking its type, we are just trying to access the method speak, but here we don't have the speak method. So this will throw an exception. Let's try to run this code. So here we can see that object doesn't have a speak method. So this is a pitfall in duck typing for Python. So now let's try something similar in a language like Java. Here we create a dog class with a speak method. But if we declare our object animal as a type object, but Java does not know that it has a speak method because Java does not know if this animal class has a speak method or not. Animal class, we have defined it as an object. So this animal variable, we have defined it as an object, not as a dog object, but rather just a simple object. So here Java does not know if this object has speak method or not. So this will throw an error. Let's try to see it in code. So here we have defined our class dog and its speak method. Here we have defined our animal variable with object class and we will try to access the speak method. Here, notice that Java does not use duck typing. So if we try to run this code, we will get error. We cannot run this because this is a compile time error. And here we can see that we cannot find the symbol, this speak. So Java does not know if this animal has a speak method or not because we haven't defined that. In case of Python, we were able to execute that. And after that, it gave us an exception. Here in Java, we are not able to execute it itself. So this code will not compile because Java checks types at compile time. So in order to fix this in Java, we use an interface. We create an animal interface with speak method, then both cat and dog implements this interface. Now, when we call the speak method, Java knows exactly what to do. This shows the difference between Python's flexible duck typing and Java's strict type system. Let's try to execute this in code. So here we have created an interface and a class dog which implements our interface animal along with cat which also implements our animal interface. Notice that this interface we have declared the speak method which we are extending in both the child classes. So here when we try to execute the speak method, Java knows what exactly do because we have implemented the speak method in our animal object which you can see here. So when we try to run this code, we can see that dog speaks woof and cat speaks meow as it's expected. So this is a difference between other languages and Python. Here, duck typing in Python follows this EAFP principle. So Python developers often follow the EAFP principle, which is easier to ask for forgiveness than permission. Here, instead of checking, let's say in this example, we have a dictionary and it has a key named name and its value as Alice. Here, instead of checking if in this my dictionary age key is existing or not, we just try to access it and assign it to our X variable. We are not asking for any permission. So we are not asking if age is existing in my dictionary or not. We just access it. And if we don't found it in the my dictionary, we just ask for forgiveness, like just by catching the same error in except block. That key is not found. This is called EAFP principle, which is easier to ask for forgiveness than permission. This is a contrast for LBYL principle. So there is another principle which says that look before you leap. So this is a second example in which we are asking for permission rather than directly trying to use it. We are asking here if age is existing in my dictionary or not. If it is existing, then only we leap to the access. That means we are after carefully checking if age is existing in my dictionary, we are trying to access it. So we are here checking for existence before accessing. So we have here two principles, EAFP and LBYL. In our case, duck typing follows the EAFP principle, which is easier to ask for forgiveness than permission. EAFP is more common in Python because it makes the code cleaner and faster. So instead of checking the key is existing in my dictionary or not, we just try to do it. So this is more cleaner and faster, and we will make sure to accept it whenever we feel that there can be any exception or error. So let's quickly recap. In Python, duck typing means we care more about what an object can do. If it quacks like a duck, we treat it as one. This makes our code flexible. But here, we must handle cases where methods are missing. In Java, we must be strict with types, often using interfaces to guarantee the behavior. And remember, Python's EAFP, which means easier to ask for forgiveness than permission styles, lets us write a shorter and more cleaner code compared to checking everything first. So that's it. If you want more videos like this or have any questions, feedback or suggestions, let me know in the comments below. Thanks for watching and catch you guys in the next one. Peace.